Okay, so here I've got a question. A tram starts from rest and moves with uniform accelerated motion for 20 seconds. It then travels at a constant speed for 170 seconds before being brought to rest with a uniform deceleration twice that of the acceleration. The total distance is 2.775 kilometers. Sketch the graph and show the total time for which it's moving. So it starts from rest, so it should be at 0 at the start. That's time in seconds. And then velocity in meters per second. So it starts from rest, so it starts at 0, and then it accelerates for 20 seconds, so its speed increases for 20 seconds at a constant rate. So constant gradient there. Then travels at a constant speed for 170 seconds. So 170 seconds of constant speed. So if this was 20, then we add on another 170, this should be 190. And then finally it decelerates, so it comes back down like that, but the deceleration should be twice as fast, so the gradient of the deceleration should seem to be a lot steeper. Now they want us to state the total time for which the train is moving. They told us to label this. It travels at a constant speed v, so we should label this constant speed right over there. We should label that v. And then what else happens? Yeah, the total distance is 2.775 kilometers. So we want to figure out the total time. How would we do that? Well, this is a velocity time graph, and we have the total distance as 2.775 kilometers. So if we want to find the total time, we know that that distance there is the area underneath the graph. We should convert it to meters though. So 2.775 kilometers as meters will be 2,775 meters. So 2,775 meters. So something like that. And then we want to go on, want to calculate the value of the time taken. So if that's the area of the graph, let's see if we can actually calculate this. Okay, so we want to find the total time. What next? Well, we don't know what to use here. If we try to use the area of that trapezium, we would say a half times the height times a plus b is equal to the area underneath, which is 2,775. So a half, what's the height? That's v. What's the a? That's one of the parallel sides. So if that's one of our parallel sides, that's how long it was moving at a constant speed. How long was that? 170 seconds. Plus how long was it moving at the... How long was this other parallel side? Well, that's total time t is equal to 2,775. But you can see we have two unknowns, so this won't work out. So for this question, actually what we're going to use is some logical ideas, logical reasoning. So we're going to think about it and say, if the train comes from speed 0 to speed v and it takes 20 seconds at acceleration a. At acceleration a, it takes 20 seconds to get to speed v. What if it decelerates even faster? So it's trying to get from speed v to speed 0. And it's doubling that deceleration, so it's slowing down twice as fast. Well, actually, instead of now taking 20 seconds, it's going to do 10 seconds. So when it slows down, it's going to take 10 extra seconds instead of the 20, because it slows down twice as fast, twice as that of the acceleration. So the time taken to slow down right there should be an extra 10 seconds. So if we ended the constant speed after 190 seconds, that extra 10 seconds will get us to 200. So 200 seconds is the total time. The 10 seconds was because the train decelerates twice as fast as it accelerated. If it accelerated for 20 and it decelerates twice as fast, it's going to take half that time. So it's only going to take 10 seconds. Now we can actually find v using the formula. So if we know a half times the height, which is v, times the sum of the two parallel sides. One of the parallel sides is 170, the other parallel side is 200. This gives us the area of a trapezium. But the area of a trapezium, we know here that's that area underneath this graph, and that is the same thing as that distance covered. So it should be 2,775 meters. So now we can try to solve this. So 2,775 times 2. So v times is equal to 5550. So we multiply the 2 on either side. So then we have 200 plus 170, which is 370. So V times 370 is equal to 5550. 5550 divided by 370, that gives us V as 15. So that's how you do it. You'd use the area of a trapezium is equal to the area underneath the graph, which was the distance. What next now? Find the magnitude of the acceleration. Well, we need to find the acceleration. We found the V is 15, so this is 15. So now for the acceleration, we're going to use SUVAT. So we're going to think about this first slanting part right there. So what's the initial velocity? Starts from rest. Final velocity is 15. We calculated the 15. The time taken to get up to that speed, how long is that? That's the 20 seconds right there. 20 seconds. So we need to find the acceleration. A is equal to V minus U over T, which is 15 minus 0 over 20, which will give us 0.75 as our final answer for that question. And that will be it. So next, let us see. That's the end of the question. That's your answer.